Hello everyone, this is Brother. So today this is a voiced recording of an animation people asked. It was done in Houdini. It's not necessarily very difficult, but it's there are so many components to that. So this recording may be a little bit long. It really depends on how far we go. So let's start. So here we in Blender. Let's start with an object, a geometry node tree. As always, I'm going to use the preset, which you can download for free from the link in the description. Let's start with a curved linear and set this XYZ into 1 so that we're having a line on Y-axis. Let's take a point instance node and duplicate this curved linear. So this time we're making back to the X, so we're instancing a line on the X-axis on the Y-axis. Okay. Take a bevel curve to give some thickness. So right now, by default, the bevel curve is using a curved circle. So we just duplicate the curved linear into the custom bevel, then it will use another curved linear. So now we're generating this kind of plane, and we can see the wireframes like this. So this kind of wireframe essentially is affected by many parameters within all these kind of counts. So you can try to deal with by yourself. But basically, I think as low subdivision will just be fine. But let's increase the subdivision here. Okay, because we're trying to extrude on this x-axis, so we do not really care the subdivision on this bevel curve or custom bevel. Okay. Then we need to do the extrusion. Talking about the extrusion, this is a little bit interesting, I guess. So there is an extrude node in 3.1. So if you just extrude, then it ends up something like this. So if you turn off this individual, then it's kind of a little bit like a solidify modifier, except that the backface is never being filled. So there will be a separate solidify node in the future, but that's another story. For the moment, since we do not really look at the backface, so I think this is just fine. There is some shading problem, but I think I will not deal with that for now. Okay. So this selection currently is exerting on every of these polygons. And we need to specify the kind of regions of how this is being affected. Since we are trying to make this extrusion wave to only work on spline, so I'm thinking about using spline parameter in 3.1. Okay. So if I directly plug these spline parameters into the offset scale, there is nothing happening. Okay. This is because there's once you bevel curve, which means you are using curve to mesh, it's no longer a curve, so there's no spline parameter. Okay. So what you do is you need to capture spline parameters before. And another thing that you need to be reminded is that these are instances, and these are instances. So there's no automatic realized instances for you to actually access each point. So right now we can see the deformation even without realized instances. But in order to have a difference later, then it will be better if you realize the instance. And we will discuss this kind of effect later. Okay. So right now this is what we're getting. Okay. So I'm thinking about how to actually animate this effect. For example, if you plug a sine function, and if you increase in the frequency, then you can see how it has been going. You have a sine function of extrusion because the sine function outputting a value from -1 to +1. Okay. I'm going to remap that to 0 to 1. So now we see this kind of wave. But I think the original animation is a kind of single wave with a kind of more controllable, how should I say, more controllable extrusion or the kind of interpolation. So it's not a predetermined parameter as a sine function. So I'm going to use the linear and use a float curve to make a customized interpolation. Okay. So something like this, trying to make it kind of straight. So we have this kind of a pattern, which is kind of good. Next thing we're going to do is to distinguish this kind of a sine function, because now these sine functions are in the same phase. So it's not kind of interesting. We're going to offset each row a little bit so that there is a difference between each kind of extrusion. So the way to do that is that we're going to use the face. So if you use this face, then you can realize there's a kind of movement, right? Okay. So how can we actually input a different value for the face? It's kind of simple that we just use another sign function, but we need to be able to get a different position value to drive another face. Okay. So I'm going to duplicate this sign function and use the position on the y-axis to take a separate x, y, z. So there is a y value, okay, and the y value can help distinguish the sign function here. Okay, if I plug this y value into the value, then it generates a different number for each row, and if I input this into the face, then we can see these changes. Let's organize the node tree a little bit better so that it becomes a little bit more linear instead of being zigzag or something like that. Okay, so something like that. Okay, so right now, if you decrease the frequency, then you can see how this wave has been formed. Finally, this is just a parameter thing. That's how you drive everything to move. And another thing that note that by changing the face, then you are moving this animation. Okay. Here, the face is changing between 0 and 1. But I think we're going to remap that somehow. So you can increase the amplitude so the face changes becomes much more prominent. So finally it looks like this. Okay. There are two kinds of issue, however. One is because we're making the sign function into a linear function. So when it's going forth and when it starts to go back, the transition of between these two states will be very abrupt, so I'm going to turn that off so that we have a kind of much smoother transition or animation. Okay. Another issue is because we remapped the sign function, which is from -1 to +1 into 0 to 1. Okay. So it only moves on one side without moving on the other side. So the other side is not being touched, which means you only have addition instead of elimination. So I'm going to turn off this remap as well, so that you can see it's kind of more back and forth movement. But even if we have done all these kind of changes, that you need to realize that our original mountains are not setting in the middle. This is the characteristic of sign function, in which sign function always starts at 0 points. But we need a kind of cosine function to reset that. But even in this case, we still haven't really made this mountain setting in the middle. So what's the actual reason? The actual reason is because this spline parameter is starting from 0 to 1. So while we think this part should be the 0, actually the 0 is here. That's why if you increase in the frequency, you can see it's always stretching to that side. Okay. So we're just going to do a little bit trick that to remap that to -1 and 1, so that if you try to increase the frequency, they're stretching towards the middle. And right now we have the mountain nicely sitting in the middle. Okay. So this is what we're looking for. So let's plug this sign function back to face, and by playing with the face, we can actually see this kind of movement as expected. Paying attention to this kind of mid-mountain, because we can see this mid-mountain is always going back and forth within the limits of this kind of spline. And this is exactly the reason why we were doing all these kind of steps, which make things kind of boring. Okay. But this is the point. However, on the other hand, in the original animation, we only see one mountain instead of 3 mountains. So here we need to understand a little bit of relationship of this kind of parameter. By increasing the frequencies, then we having this mountain being narrowed. But on the other hand, we are creating an extra mountains. Okay. So we need to be able to eliminate these kind of extra mountains using a mask. The way every time you're working with a mask is basically you just use a multiply function. Okay. But the question is how to generate this kind of mask. So let's set a multiply. If we multiply the 0, then it's nothing. So we would like to keep these kind of 2 shaded areas to be 0, while the middle part to have a value of 1. So what do we do here? It's kind of a little boring to explain, and it's also difficult to explain as well. I would like to get a frequency number. You won't actually see why. So within sine function, while this node looks kind of complex, but in reality, for frequency, phase, and amplitude, it's basically just in addition to sine function, you have add, multiply, add, and multiply, something like that. It's just the 5 math nodes. So instead of using 5 math nodes every time, I'm constructing them into a sine function preset. Okay. So in this case, we just use the same concept. That's instead of using the frequency here, I'm using the frequency outside for a specific reason. And then I'm going to turn this value into absolute, because right now this is a -1 to +1, which has been multiplied into -8 to +8. Okay. So we turn that to absolute, and we're going to do a compare function. So take a compare node. So if it's less than a certain number, then it's outputting a value of 1. Other than that, it's just outputs a value of 0. Okay. So right now, if I plug this result into place, there's nothing happens. But if I increase these values, then you realize what's going on. Okay. So you can actually see we are having a mask. Okay. So this mask is not perfect because we haven't linked all this kind of mathematical function into the phase. Okay. Because the phase is moving all these kind of mountains. That's why sometimes there's a kind of inconsistency in between them. But adding the phase is just an add math to this sine function. So now it becomes completely perfect. However, you actually change that. Basically the mask moving with this kind of phase and the mountains, so you can move them without any problem. If you do not have this mask function, then you can actually see the issue, because the mask is always generating in these areas without moving with the phase. That's why we need this math function. Up to now, we have finished the basic concept of this entire setup. Okay, the rest is really just about adding more settings and more variations and so on. Okay, so one thing that you need to realize from the original animation is that there's a change of width along these kind of rows. And previously I've already mentioned that by changing width, we deal with this frequency. And in order to create this kind of mask, we are taking this frequency outside using this mask node. Okay. So now if we just increasing or decreasing these values, then you can see there's a change of width, which is due to frequency. Okay. Another thing we would like to change is change the amplitude. But if you just increasing this amplitude, you can see there is a weird result. That does not really change the amplitude, but something's wrong. The reason is that since we're using this float curve to change the interpolation, there is actually an automatic clipping. And this kind of setting another exposed outside, such as the map range. So instead of using this amplitude here, we're going to extract this amplitude outside as well, just like we do with the frequency. So it's just another multiplier. Okay. So this is also actually a moment that illustrates how we constructed this node group and how important this node group. Because if without this node group, sine function is just to keep stacking all this kind of multiply, addition, subtract, and so on and so forth. Okay. So now we know there's a multiply to care about. There's another multiply to care about. Okay. And the rest is just to add the sine functions into them. So let's organize the tree a little bit better. So let's give a little bit more space, because we just need to stack more sine functions into this place. So let's Control-Shift-D so that we duplicate with this linkage. And we also need to add a value node so that we can synchronize the phase changes on each of these sine functions. And then we just plug this sine function into the place, and another sine function into the other place. Okay. Instead of doing that, just illustrate this effect a little bit more. Okay. So right now you need to understand that higher this amplitude means higher the frequency means narrow in the mountain. Okay. So you need to do a little bit of kind of a trick, for example, remap the to 0 to 1, so that you probably would like to really use a map range. So keep the amplitude as 1 so that it's easier to manipulate. So the minimum is like this. So finally, if you just changing this phase, then you have this kind of effect. Okay. Another is about the amplitude. We basically need to do the same. I think we also need a map range. So plug this into the other multiplier. So we need to determine this minimum amplitude. So the minimum height should be, let's say, so minimum height, let's say it's 0.27. Our frequency needs to be, so minimum height, let's just 0.1 or something. Also decrease the frequency, changing the frequency to be a kind of normal values, increasing it. So now if I change this value, you can see there's how it has been changed eventually. Okay. So basically this is how this animation is essentially being done. The rest is just the parametrical things I'm not going to discuss extremely much. Basically, if you would like to add any other kind of variation, for example, the color change within the original animation, you just keep stacking all these sign functions and output your attribute and so on and so forth. Okay. Also I want to remind you that this setup is kind of procedural. So here, if you increase the count, you do not, you are increasing the resolution of this kind of extrusion. So kind of a subdivision smoothing out of that because you have more faces being generated here for the extrusion. Okay. Another setting is this kind of count. If you increase the count right now, because this is the stop mode without checking this box, then you're increasing the amount of the instances in the middle. Here I'm going to switch that into the step mode so that from point to point there's a consistent amount of interval, so that you're increasing the value just expand onto this onto our axis. Okay. So this is in case you would like to increase the amount of whatever stuff. And another thing that you can potentially do is to increasing all these kind of frequencies. So there's a lot of control that you have, but I'm not going to discuss too much. At the end, I'm going to do a kind of inset functionality, but I do not really think geometrynodes is very good at insetting things. So what we are doing here is we're going to only extrude the side, which is basically this surface. Okay. So immediately we do not really see anything, but if you plug a scale element and scale only the top, then you start to see this kind of only the middle part being inset. And we're also going to translate that. In this case, I'm just going to translate based on normal, so let's just tweak with this normal displacement. We're still going to use the stop, and by tweaking this value, you can see how it has been changed. Okay. But by using this top selection, it's not very perfect because you can see the sidebar has also been pushed inwards. So it seems like we need to do another method using the normal, which is for these kind of faces, they are facing either positive y or negative y. Okay. So here we need to take a separate x, y, z. And since we need to evaluate both positive and negative, so the easiest way is just absolute. And then compare. Compare greater than. Yes. And then plug into the selection. So greater than certain values, they will be selected to inset. Otherwise, they won't be selected. Something like that. This is just an example. In reality, I do not exactly know how it should be done. But I think you get a kind of idea, then it will just be fine. Okay. Of course, this is just a workaround to compensate the missing of the inset operation within geometrynodes. But yeah, anyway. And this selection can also function for the color changes or other things. But I don't think I'm going to touch that for real. I don't think it's worth that. I suppose there's other ways. For example, perhaps we can inset the top, extrude the top part. So for example, let me see. Yeah. So this is also a way. I think this way is actually better because we are adding the thickness. And then we just normal displacement with the original, we still use the same selection. Let's see how it has. Yeah, I think this method is actually better than the previous. Yeah, I think this definitely is better. So you get a kind of idea. So I think this will be just it for this one. Okay, looks fine. So finally, let's just do the kind of material very quick. We need to set two materials based on the selection. So let's add two materials. One is to be the emission shaders. So material A and material B with the emission for the selection. Okay, and we need to output the sine function from previously. So I just need to borrow the sine function. So let's take this sine function, merge them together because the setting are completely the same. And I'm going to output this sine function to the group output. So within the attributes, let's just name it as a C. And goes to the material shaders, slots, take an attribute for the C. Plug the colors into color. So if now I go to material preview mode, we can see this kind of gradation. And let's just turn on this time to 1000. And instead of using the value to scroll this value, I'm just going to turn on this time info node so that everything is driven by the same time. And now if I play this animation, you can see this kind of color change as the sine wave is being progressed. Okay, so basically this is it. So I hope you enjoyed this video. I'll probably see you next time. Bye bye.